Good morning. This is your video study guide for the astronomy unit. All you need is a piece of paper and something to write with. You see that I'm doing mine in pen, but you might want to do yours in pencil. I'm going to go over most of the things that are going to be on the test for astronomy that's coming up. So if you go along with me and write down what I write and draw what I draw, it will help you remember some stuff. I'm going to try to do it small, see if I can fit it all on one piece of paper, but we may have to go on to the second piece of paper. First and foremost, let's talk about the difference between the universe, a galaxy, and a solar system. The universe is everything in outer space, all the stars, all the galaxies, all the planets. The universe contains billions of galaxies, which themselves contain billions of stars, often hundreds of billions of stars. And the solar system is one star with some planets. Sometimes solar systems are binary, meaning they have two stars, but that won't be on the test. There are three types of galaxies. You've got your Milky Way style galaxy, that's a spiral galaxy. You've got your slightly more oval shape, that is your elliptical galaxy. And then you've got one that's any old shape, and that's called irregular. And these are types of galaxies. All right, we've also got a very important part of the curriculum, the Big Bang Theory. The Big Bang Theory states that all of the universe started as one dense and hot cluster that expanded rapidly 13.8 billion years ago. Anytime you see BYA, that's billion years ago. MYA is millions of years ago. And right after the Big Bang, you have the birth of the earliest stars and the earliest galaxies. Sometime after, you have our sun. So our star, which we call the sun, that formed about 4.6 billion years ago. And the universe is still expanding with new stars and new galaxies being created all the time, and it's getting wider and wider. It's important to talk about some of the evidence for the Big Bang Theory. The main thing you need to know is red shift. That means that galaxies are moving away from us, and they shift slightly towards the red side of the visible spectrum of light. They give a red tint when they're moving away, and they are all moving away from us. That's how the universe started. When we talk about how individual solar systems formed, we need to talk about solar nebula theory. Solar nebula theory states that all stars start off as something called a nebula. A nebula is like a cloud of space dust and gas. And after the nebula stage, they can go into two pathways for the star life cycle. For stars like our sun, we are average stars. Or it could be a larger star that we call a massive star. During this phase of their life cycle, stars are burning hydrogen fuel into helium in a process called fusion. two hydrogen atoms turning into a helium atom. When they run out of hydrogen fuel, they expand into a giant star. If they were already a massive star on the larger side of things, it's called a supergiant. And still a giant star, but a little bit smaller, you'd have your red giants. We think that our sun will eventually become a red giant in about 5 billion years. During this phase of their life cycle, for the giant stars, it's still fusion, but they're taking those helium atoms and building larger elements through fusion, such as iron and nickel, metals like magnesium, but all the elements in the periodic table, everything that we know about, did come from inside of a star at some point. The death of a smaller star happens in something called a planetary nebula. The death of a larger star is a huge explosion called a supernova. After the planetary nebula for average stars, they become a star called a white dwarf, which is kind of just the core of a star left behind. It is very hot, but not very bright. If it's a supernova, that results in either a neutron star, which is also a dead star, or a black hole, which is an extremely dense star that's collapsed in on itself, and its gravitational field is so strong that not even light can escape. So I'm kind of blocking off little sections here that talk about different things. That's the solar nebula theory there. When we're talking about stars, we can plot any star, no matter where it is on its life cycle, on the HR diagram. HR diagram can show a few different things, but primarily its temperature in degrees Kelvin on the x-axis and luminosity as compared to our sun on the y-axis. And the funny thing about most HR diagrams is that the hottest temperatures are on the left and the cooler temperatures, like 5,000 degrees Kelvin, cooler temperature for a star, is all the way on the right side. Luminosity is on a logarithmic scale. It's just kind of a condensed scale, because the distance from 1 to 100 looks the same as the distance from 100 to 10,000 on the graph. That's what it means to have a logarithmic scale. And most stars in the universe are what you call main sequence stars. They have a positive relationship between temperature and luminosity. Our sun falls right in the middle of the main sequence. At the bottom left, you have your super hot, but not very bright white dwarfs. And in the top right, you have your giant stars and your supergiant stars. And there's usually more than one of these, but for the sake of time, I'm just drawing a few. Remember, this thing in the middle, the line across, is called the main sequence. So giant stars are very bright but less hot. White dwarfs are super hot but not as bright. And main sequence stars, the hotter they are, the brighter they are. Okay. Just a little more about nuclear fusion. Nuclear fusion is combining two atoms into a larger atom. They are fusing together. And when that happens, energy is released. And that's the opposite of fission, which splits the atom. That's what happens inside a nuclear power plant or a nuclear bomb. Let's see, what else do we need to know? We're going to move on to the solar system that we live in. We've got our sun, and then we've got 4 inner planets that are known as the terrestrial planets. We've got the asteroid belt. Then we've got 4 larger planets known as the gas giants. And then we've got the Kuiper belt. So the inner rocky planets those are Mars, Venus, Mercury, Venus, Earth, Mars, my very educated mother, Mercury, Venus, Earth, Mars, my very educated mother, just served us nachos. That's an N. That's why you should work in pencil. So, Jupiter, Saturn, Uranus, and Neptune. And terrestrial planets are the 4 inner ones. These outer ones are called the gas giants. And in the middle, we have the asteroid belt. And at the end, we have the Kuiper belt. Asteroid belt is lots of little asteroids, some of them big, some of them little, floating in outer space between Mars and Jupiter. And the Kuiper belt is a similar thing, but it has within it dwarf planets, including Pluto, which used to be considered a planet before they discovered all these other little dwarf planets and said, well, we're going to have